How to write a non-recursive program. Suppose we want to write a factorial program. So how we are going to write? We're going to write fact int n. We have taken variable int a, which we initialize with one value. For loop, initially I value is 1. It will go up to I is less than n and I plus plus. Then every time a is equals to a into I. The loop will run, it will execute a is equals to a into I until I value is less than equals to n. Then return a and close the main program bracket. So this is the program for factorial n, but this is non-recursive program. So we can simply see how many variables we are using. We are using 3 variables here. One is n, second is a, and third is I. So total number of variables are 3. So we can say, and all are of integer type. All 3 variables are of integer type a, I, and n. So because integer type, so how many bytes it's required? Because integer one variable take 2 bytes, so for 3 it will take 6 bytes. So in one function we can say space, how much space is required? 6 into 1 means 6 bytes at one time, because as we initialize it, then it will take 6 bytes. As soon as we initialize the variable, it will take bytes according to the data type. So 6 bytes, so 6 into 1, so we can say order of 1 at one time. But if we talk about the time complexity, space complexity, we can say order of 1. But if we talk about the time complexity, that how much time it will take, because here is for loop is there and it will run up till n time, so the time complexity will be order of n. Time complexity will be order of n. So we can say with recursion, space complexity is greater. Here we can say space complexity is less, and this program is, we have written this program. We can say this program is non-recursive because no function is calling itself. But if we talk about the recursive program, so we can say with recursive program, space complexity will be greater. Space complexity will be greater, and the time complexity may be greater or not, but the time complexity may or may not greater with the recursive program. And if we talk about without recursion, the space complexity, here we can see clearly this program is without recursion. This is non-recursive program, so space complexity is small, order of 1 only, so this is small. Why this is small? Because we remove the function call, or we can say function is not calling itself. Function is not calling itself because this is non-recursive program. This is non-recursive program. So we can say there are two things about a recursive and non-recursive program. What they are, we can simply say recursive program easier to write. Recursive program easier to write, but take more space as compared to non-recursive program. And what else we can say? For every recursive program, we can write equivalent non-recursive program with the help of loops. What kind of loops we can use? We can use for loop, while loop. We can use for loop, while loop. As in this program, what we have used? We have used for loop. So in that way, we can solve the program, and we can write a non-recursive program. And this is the basic difference between recursive and non-recursive program. So what else we can say? To solve a recurrence relation, what kind of methods we have? We have three kinds of method to solve a recurrence relation. First is substitution method. Second is recursive tree method, and the third is master theorem. So in our next lecture, we will learn how we can use or how we can write a recurrence relation with the help of substitution method.